Imagine, just imagine for one moment, a warm summer day. You are sitting on the porch, your eyes closed. A sunbeam, golden and thick like linden honey, lies on your skin. You feel it. Not just see it, but truly feel it with your entire being. You feel how myriads of invisible little hammers gently tap on your cells, awakening them to life, making your blood run a little faster. This sensation is as ancient as life itself on this planet. A feeling of safety, a feeling of home. There is something fundamental in this warmth, something woven into our DNA at the deepest level. Warmth is life, cold is something else. But then the sun hides behind a cloud for just a minute, and you immediately shiver. The warmth leaves, and its place is taken by coolness, as if an invisible veil has covered the world. And at night, when our fiery protector disappears beyond the horizon altogether, the cold becomes palpable, almost predatory. It seeps under your clothes, makes you seek shelter, and the world outside the window seems alien and hostile. This is our first case. Case number 1, the simplest and the most complex. The case of the sunbeam and the night coolness. At first glance, everything is obvious. So obvious that it's even awkward to open an investigation about it. On the table before us lies a thick folder, and in it is the testimony of the main suspect. A suspect whom we have trusted all our lives, who has whispered answers to all our questions since childhood, shaping our perception of the world. The name of this suspect is intuition, or, if you prefer, its partner. More direct and crude, everyday experience. And what does it tell us, this reliable partner? It says, "It's simple, detective. There's a giant hot thing, the sun. When you face it, you're warm. When it turns away, you're cold. It's hot near a campfire, and not near it. What is there to investigate? Don't waste my time. We have more important things to do." And you know what? There's logic in its words. Iron, earthly, familiar logic. It is so convincing, our old friend. Common sense. It slaps us on the shoulder and suggests closing the case for lack of corpus delicti. Any prosecutor would dismiss such a case, laughing at our meticulousness. But a good detective always feels when testimony is too smooth, too simple to be true. It lacks snags, lacks contradictions, and that's precisely what makes it suspicious. And here we ask the first question. A question that makes our suspect fidget nervously in his chair. A question that turns this simple domestic case into a case of cosmic proportions. Well, let's assume your testimony is noted. But answer me this. Between us and the sun, there are 150 million kilometers of empty space. If it's supposed to be unbearably hot near the sun, this thermonuclear monster, then why is space itself, which is much closer to it than we are, not just cool, but icy? Why does it freeze to a temperature of minus 270 degrees Celsius? Silence. Our suspect, our intuition, is silent. It doesn't know what to say. Its neat theory, which worked perfectly for a campfire in a forest clearing, disintegrates into dust when confronted with the scale of space. It's used to heat being transferred through something, through air, which becomes warm and touches our skin, through water, which burns through the metal handle of a frying pan. But space is a vacuum, emptiness. There's nothing to heat up in it. So how can it be cold? How can we even talk about the temperature of emptiness? It's like talking about the color of silence or the weight of absence. This is the corpus delicti, a crime against the logic we are accustomed to. A giant nuclear reactor the size of 100,000 planet Earths, spewing out more energy every second than all of humanity has consumed in its history, cannot warm the space a few steps away from itself. It is surrounded by an icy abyss of velvety blackness that seems to indifferently absorb all its fury. This is the strangest crime scene imaginable. The investigation begins, and we must define the roles. We are detectives assigned to this hopeless case. Our brain, our common sense, is the main suspect, whose testimony we will question at every step. The laws of physics are the statute, a set of rules that cannot be broken. Every scientific concept is a piece of evidence that we will examine under a microscope, looking for fingerprints of truth on it. And the great scientists of the past, Einstein, Planck, Boltzmann, are our witnesses, whose diaries and notes will help us shed light on this dark case. We must personify the problem to understand its essence. Space is not just a place, It is a silent, indifferent witness to the crime. It has seen everything, but it will not say a word. It must be made to speak, using the right tools. The sun is not just a star. It is a source of energy of such unimaginable power that its alibi seems impeccable. It cannot help but radiate heat. It screams of its warmth, but its cry drowns in the surrounding silence, as if in a soundproof room. So, what do we have at the beginning of the investigation? Exhibit number 1. A heat source of colossal, almost infinite power. Exhibit number 2. Icy cold in close proximity to this source and shaky, unconvincing testimony from the main suspect, who insists that this cannot be and is clearly confused in his own statements. A contradiction is evident. To understand where exactly our intuition is lying, where its neat logic cracks, we will first have to clarify the most basic concepts to give it its first aggressive interrogation. We must put it under a bright lamp and ask directly. You constantly say, warm, cold, but do you even know what that is? What is temperature, really? And this is just the beginning of our investigation. The very first piece of evidence we examine in the next chapter will make us doubt everything we knew about the world through our own senses. We will understand that our feelings, our touch, have been deceiving us all our lives, giving us a simplified, edited version of reality. We are on the verge of seeing how the simple concept of temperature transforms from a domestic sensation into a key to the mysteries of the universe. We are in an interrogation room. There are no windows, no unnecessary details, only bare walls, a table, 2 chairs, and a single lamp overhead, casting a sharp circle of light. Opposite us sits our suspect. He is invisible, but we feel his presence. It is our intuition, our common sense. He sits, slouching slightly in his chair, confident in his rightness, and waits for the first question. He considers this procedure a mere formality, and we ask it. What is temperature? He chuckles. The question seems childish, even insulting to him. Temperature, he replies, shrugging his shoulders. It's just, take this cup of coffee. It's hot, and here's a piece of ice. It's cold. Temperature is a property of an object, its internal quality. What's so hard to understand? Hot burns, cold freezes. It's a fundamental property of the world. It just is. His answer is impeccable. It is based on millions of years of evolution, on billions of touches, on the personal experience of every living creature. Hot, painful, stay away. Cold, unpleasant, seek shelter. This is an axiom of survival, written into our genes. But for our case, for the case of icy space, this testimony is a red herring. It leads us into a dead end, a vicious circle of everyday notions, and we must prove it to him. We must show him that the world is structured completely differently than he is used to thinking. Let's look at it from another angle, we say, sliding the first piece of evidence towards him, an invisible photograph of the microworld. Forget your senses. They are bad witnesses, biased and limited. Let's talk about what actually happens, at a level invisible to the eye. Imagine a huge empty ballroom. This is our room. Now let's release 1,000 dancers into this hall. These are air molecules. What do? They don't stand still. They rush around the hall, collide with each other, bounce off the walls. They dance. And here's the key to the riddle. Temperature is nothing more than the average speed and energy of their dance. Not a property, but a process. Not a state, but an action. When we say hot gas, we should imagine a frenzied, furious techno slam at a rock concert. The dancers rush around like madmen. Their movements are chaotic, fast, full of energy. They crash into each other with such force that they threaten to tear down the entire hall. This wild, unstoppable dance is what we perceive as high temperature and high pressure. When we say cold gas, imagine a slow, lazy, almost sleepy waltz by candlelight. The dancers twirl smoothly, moving lazily from place to place. Their collisions are rare and weak. There is almost no energy in their dance. They barely move. And what is absolute zero? Minus 273.15 degrees Celsius. It's not just very cold. It's not just a slow dance. It's the moment when the DJ suddenly turns off the music and the lights go out in the hall, and every single dancer in the hall freezes in place in complete, absolute silence. Movement ceases. The dance is completely over. Our suspect, intuition, begins to understand. Its confidence melts like snow in one's palm. It always thought of temperature as something static, a property inherent to an object, like color or weight. But it turns out to be movement, energy, a dance. And this clue, this simple analogy, known as the kinetic theory of gases, completely changes the rules of the game. It proves that to talk about temperature at all, we need dancers. We need particles, atoms, molecules. In an absolutely empty hall, where there isn't a single dancer, there can be no dance, and there can be no temperature. But how do we make these dancers move faster? How do we transfer energy to them? How do we heat the room? In our investigation, there are only 3 ways to transfer evidence. 3 ways that heat can travel from one point to another, and we must check the alibi of each of them. Method 1. Thermal conductivity, or in our language, hand-to-hand transfer. Imagine a line of prisoners standing close to each other in a prison corridor. You push the first one, he pushes the second, the third. And so the vibration passes through the entire chain. This is precisely how heat is transferred in solids. Atoms, tightly packed in a crystal lattice, transfer their vibrations to their neighbors. This is how a poker, stuck into a fire at one end, gets red hot. But what is the alibi of this method in our case? Ironclad. In space, where the density of matter is about 1 atom per cubic meter, our prisoners are kilometers apart. The chain is broken. There is no one to transmit vibrations. This method doesn't work. The case is closed on this account. Method 2. Convection or transfer by courier. Imagine a pot of boiling water. The water at the bottom heats up from the fire. Its density decreases, and as it becomes lighter, it rushes upwards, making way for the cold, heavy water from above. This circulation, these currents, are convection. Likewise, warm air from a radiator rises to the ceiling, heating the room. Heated particles, our couriers, personally carry heat from place to place. The alibi of this method is even more obvious. In a vacuum, there is no liquid, no gas, no medium. There are no couriers themselves to carry packages of energy. This method is also ruled out. It has a 100% alibi, and so only one suspect remains on the table. Only one way for the sun to share its warmth with the surrounding world. Method 3. Radiation, the only remaining witness. This method is the most cunning and the most fundamental. It needs no intermediaries. It transfers energy directly without any chains or couriers. It does this using electromagnetic waves. Photons are like a radio signal that travels through emptiness and needs no wires. The sun does not touch us and does not blow warm air. It shouts its warmth in all directions using light, visible, infrared, ultraviolet. And this cry reaches us across 150 million kilometers of vacuum. It seems the case is almost solved. Intuition is defeated. We understood what temperature is, and we found the only culprit capable of delivering heat from the sun to the earth. This is radiation. It is logical to assume that this same radiation should also heat everything else in its path, including space itself. But that's the problem, isn't it? Our only witness seems to be hiding something. It admitted to delivering energy, but it's withholding the main point. Why doesn't this energy ignite the air itself as it travels through? Why is a beam of light from a powerful spotlight in a dark room visible only when dust particles are in its path? We have caught our witness in a half-truth. It told us how it travels, but not how it transmits its message. In the next chapter, we will examine its testimony under a microscope. We will break down its essence into parts and understand that its words and light itself are only half the truth. The real magic happens not at the moment of sending, but at the moment of receiving. Now we must descend even deeper into the nature of reality. Our interrogation is over. The room is empty. We are left alone with the only piece of evidence, the only witness that could not provide an alibi with radiation. Now we must not just interrogate it, but perform a full autopsy. We must understand who it is, this mysterious courier flying through the void. The name of this courier is Photon. Our intuition, our defeated suspect, is used to thinking of sunlight as a continuous stream of heat, like water from a hose. But this is not so. At the beginning of the 20th century, a witness named Max Planck and after him Albert Einstein, proved that light behaves differently. It comes not in a stream, but in portions, quanta, as if someone is shooting at us with a machine gun of microscopic massless bullets of energy. These bullets are photons. The sun is a giant machine gun that fires an unimaginable number of these energy bullets in all directions every second. A number with a trailing string of zeros. There are so many of them that it seems to us like a continuous stream. But this is an illusion, and here is the first lead in our case. Okay, you'll say, bullets are flying, but they must hit something. Why don't they hit space itself? And here we encounter the first amendment to the law, a clue that explains much, but not everything. It is the law of inverse squares. It sounds complicated, but in reality, it's simple. Imagine you are standing next to a huge roaring campfire. It's unbearably hot. Energy hits your face. Now step away 10 paces. It's noticeably cooler. Step away 100 paces, and you'll barely feel its heat. What happened? The fire didn't start burning weaker. Its energy simply spreads in all directions, distributing itself over an ever-increasing area. This area grows as the square of the distance. Increase the distance by half, the energy density drops by 4-fold. Increase it 10-fold, it drops 100-fold. The same happens with the sun. At its surface, the energy is monstrous. But at Earth's orbit, at a distance of 150 million kilometers, this energy is already spread over a giant sphere with an area of 280 quadrillion square kilometers. The energy flux that reaches us is already significantly weaker, billions of times weaker, than at the surface of the sun itself. This is an important circumstance. It explains why we are not instantly incinerated, but it doesn't answer the main question, because even this weakened energy flux is still colossal. The solar constant, as scientists call this flux, is about 1,360 watts per square meter. It's as if for every square meter facing the sun, a powerful heater is working continuously. This is more than enough to turn our planet into a frying pan from hell, and it should certainly be enough to warm the emptiness right next to the sun, at least a little. But this is not happening. Why? And here we come to the crucial point of the entire investigation. To an idea so simple and at the same time so profound that it changes everything. Radiation itself, the photon, is not heat. Let me repeat, so that you realize the weight of this clue. Light is not heat. It is a carrier of energy. It is a package, but not its contents. For heating to occur, for that very temperature we talked about in the last chapter to appear, that is, for the dancers, the atoms, to start moving faster, they must receive that package. The photon must be absorbed by some substance. Imagine it like this, a boundless dark field. At one end of the field stands a super-modern machine gun firing baseball bats. This is our sun and its photons. At the other end of the field, you stand. This is Earth. The bats fly at tremendous speed. If you don't catch them, they'll just fly past you. Nothing will happen. But now you put on a special trap on your hand. This is our atmosphere and surface. And now you catch the ball. What do you feel at that moment? A push, a blow. Your hand vibrates. This vibration, the vibration you felt catching the ball, is heat. Temperature is the tremor in the body of the player who caught the ball. Now look at the space between you and the machine gun. At the field itself, it's empty. Billions of bats whiz through it every second. But in the field itself, there are no players, no traps, no atoms or molecules that could catch these bats. The bats, the photons, simply fly by. They cannot transfer their energy to emptiness. There is no one to transfer it to. Therefore, space itself, the vacuum itself, remains cold. It doesn't catch bats. It's just a transit zone for them. This is why we see a beam of light in a dusty room. The dust particles are those very microscopic players that catch photons and immediately re-emit them in all directions, including into our eyes. No dust particles, no visible beam. Light exists, but we don't see it because it doesn't interact with anything on its path. A photon is an ideal courier, almost ideal. It is born in the thermonuclear hell of the sun's core. For hundreds of thousands of years, it makes its way to its surface and bursts into open space. It doesn't age, doesn't get tired, and doesn't lose its cargo, its portion of energy, along the way. It can fly through emptiness for millions and billions of years, remaining absolutely unchanged in its pristine form. It will fly until it collides with something, with a gas atom, a dust particle, a planet, the retina. The eye of a detective trying to unravel its mystery. Only at the moment of this collision, at the moment of absorption, does its journey end, and its energy is transferred to the target. So, it seems the verdict is in. Space is cold, not because the sun heats poorly, but because space is emptiness, and there is nothing to heat up. The case can be closed. Our intuition was wrong because it didn't know about the quantum nature of light and the difference between energy and temperature. But a good detective never rushes to conclusions. He always asks one last question. You said emptiness. You said vacuum. But is that really the case? Are you sure there isn't a single, even the tiniest player in this dark field? And here, something incredible is revealed. Space is not entirely empty. It is permeated by a ghost, an invisible, all-penetrating echo of the most ancient and most grandiose event in the universe. And this ghost has its own base temperature. It is the very background cold that we are looking for. In the next chapter, we will go in search of this ghost. We will find fingerprints left at the moment of the birth of time, and we will understand that the universe has its own inevitable cooling temperature. We are on the verge of witnessing the birth of cold itself. Our investigation has reached a dead end that at first glance seems final. The verdict is ready. Space is cold because it is empty. Because the photons flying from the sun, these microscopic energy couriers, simply have nothing to collide with, no one to interact with, no one to transfer their heat to. The case can be archived. Our intuition, accustomed to a world filled with matter, has been shamed. But a good detective knows that the most obvious conclusion is often just a screen behind which a much deeper and stranger truth is hidden. And he asks himself the last, most important question. Is space truly as empty as we think? We begin the most thorough search at the largest crime scene in the universe, in the void of interstellar space. What do we find? At first glance, almost nothing. The density of matter here is unimaginably low. On average, there is only one hydrogen atom per cubic meter of space. To comprehend this emptiness, let's conduct a thought experiment. Imagine that one atom is a single grain of sand. In that case, in the air we breathe right now, in a volume of 1 cubic centimeter, there would be about 50 quintillion such grains of sand. But in space, a single grain of sand floats alone in a space the size of a vast cathedral. Trying to heat space by shooting photons at it is like trying to heat that cathedral by shooting a rifle at it, hoping to hit that one single grain of sand. The odds are negligible. This seems to only confirm our initial theory. But the search continues. We turn on our most sensitive instruments, and suddenly we hear it. A hum, a quiet, monotonous, all-pervading hum. It comes from everywhere at once. No matter where we aim our antennas, whether towards distant galaxies or into the darkest starless void, it is there. It is absolutely uniform in all directions. This was not the kind of noise one could dismiss as interference from distant stars. It was too smooth, too constant, as if the very fabric of space were quietly humming on the same note. This clue first entered our case quite by chance in 1965. Two radio astronomers from Bell Labs, Arno Penzias and Robert Wilson, were working with a large horn antenna in New Jersey. They were trying to tune it for observations of the Milky Way, but they were bothered by a constant, unexplained background noise, corresponding to microwave radiation with a temperature of about 3 degrees above absolute zero. They did everything a diligent investigator would do. They checked all the equipment. They reoriented the antenna. They thought the noise might be coming from New York City. But that, too, was not confirmed. They even proposed the famous theory that the source of interference could be pigeons that had nested in the antenna and what they called white dielectric material, in simple terms, bird droppings. The antenna was thoroughly cleaned, but the noise persisted. It was stubborn and ubiquitous. Penzias and Wilson were desperate. They had found a clue they couldn't explain. At the same time, just a few dozen kilometers away, at Princeton University, another group of detectives led by Robert Dick was working on a theory. They hypothesized that if our universe was born in a gigantic hot explosion, then an echo of it, cooled from its glow, should remain, permeating all of space and having a temperature of only a few degrees above absolute zero. They were just assembling equipment to begin searching for this signal. And then, as in a good detective novel, one of the members of the Princeton group accidentally heard about Penzias and Wilson's problem. A phone call was made that changed cosmology forever. One team had found a corpse, not knowing who it was. The other team knew of a missing person, but didn't know where to look. Together, they solved one of the greatest cases in scientific history. What they found was not noise or interference. It was the voice of the infant universe. It was the cosmic microwave background radiation. To understand what it is, we need to rewind the tape of our investigation 13.8 billion years ago. In the first moments after the Big Bang, the universe was an unimaginably hot and dense point. It wasn't just a point, but a seething, opaque soup of elementary particles: protons, neutrons, electrons, and photons. In this infernal plasma, it was so hot and dense that light could not travel freely. Photons, our messengers, constantly collided with charged particles, primarily electrons, and were immediately absorbed. They were trapped in this plasma prison, like fireflies in a jar of honey. The universe was completely opaque, but it was expanding, and as it expanded, it cooled. And when the universe was about 380,000 years old, a negligible moment by cosmic standards, the temperature dropped to about 3,000 degrees. At this temperature, a key event occurred, which physicists call the epoch of recombination. Cooled protons and electrons were finally able to combine and form the first stable, electrically neutral atoms of hydrogen and helium. The fog dispersed. Particles that had previously trapped light became neutral. A path suddenly opened for photons. The prison disappeared. The light that had last collided with matter at that moment was set free and rushed out in all directions. Since then, it has been traveling through the ever-expanding universe, and as space stretches, the wavelength of this light also stretches. Yes, it loses energy. It cools. The light that was once blindingly bright and hot, like the surface of a star, has stretched so much over 13.8 billion years of travel that today we detect it in the microwave range, and its temperature is 2.725 degrees on the Kelvin scale, or minus 274.5 degrees Celsius. This is the final answer to the question of the temperature of space. This is its basic background temperature. This is the temperature of the cooling ashes from the bonfire of creation. Any object left in deep intergalactic space, far from starlight, will eventually cool to this temperature, radiating its heat into the surrounding void. This is the inevitable cold of the universe, its natural state. So, we have a verdict for deep space. It is cold due to the almost complete absence of matter capable of absorbing stellar energy, and due to the cooled echo of the Big Bang, which sets the basic temperature for all existence. The case of cold in space seems to be definitively solved, but by solving one case, we have immediately opened a new, even more intriguing one. If the entire universe is permeated by this deathly cold, then why are we here, on our little planet, so warm and comfortable? Who or what protects us from this universal chill? We are on the trail of a new suspect, our guardian angel, who, as we will soon learn, could easily become a traitor and executioner. His name is the atmosphere. We close the file on the cosmic microwave background radiation and shift our investigation from cosmic scales to a local level. We return home to our pale blue dot, which appears as such an anomalously warm island in the icy ocean of the universe. Our new suspect, the atmosphere. At first glance, it is our protector, transparent and weightless. We look through it at the stars. We breathe it. We live at the bottom of this giant ocean of air, barely noticing its presence. But in our case of warmth, it plays a key role. It is the main accomplice, without whom the crime called life would be impossible. To understand its role, we must realize that our atmosphere is not just a mixture of gases. It is a complex, multi-layered mechanism that performs two vital but completely different jobs. It is simultaneously our shield and our blanket. Its first job is that of a bodyguard, a shield from the sun, as we already know, and it radiates not only life-giving light and heat. It bombards us with a stream of deadly radiation, hard ultraviolet rays, X-rays, and streams of charged particles known as solar wind. If this stream were to reach the surface unimpeded, it would sterilize it, destroying DNA and making life impossible. But we have protection. First, the Earth's magnetosphere comes into play, an invisible force field that deflects most of the charged particles. But what breaks through encounters a second line of defense: the upper layers of the atmosphere. In the stratosphere, at an altitude of 20 to 50 kilometers, lies the ozone layer. This thin layer of gas, composed of trioxygen, is our tireless guardian. Ozone molecules absorb the most dangerous part of the ultraviolet spectrum, the part carrying the most energy. They essentially take the blow upon themselves, breaking down and reforming in a continuous cycle. This is our celestial grill that prevents the sun from frying us alive. It filters out the deadly rays, letting only the gentler, life-essential light pass through. But the job of the shield is only half the story. After protecting us from harmful radiation, the atmosphere proceeds to a second, even more cunning task. It transforms into a blanket, and the mechanism of this blanket's operation is known to us as the greenhouse effect. Here, our accomplice displays all its insidious genius. Let's follow the clues step by step. Step 1. Sunlight, predominantly in the visible range, has a short wavelength and high energy. Most gases in our atmosphere, mainly nitrogen and oxygen, are practically transparent to this light. It passes through them with almost no obstruction, like light through clear window glass. Step 2. This light reaches the Earth's surface, land, and oceans. The surface absorbs this energy and heats up. Everything that is heated begins to emit heat itself, and this is the key point. Step 3. The heated Earth radiates energy back into space, but it does so not as visible light anymore. It radiates in the infrared range. This radiation has a longer wavelength and less energy. This is the very heat you feel from heated asphalt or a central heating radiator. And this is where our blanket comes into play. It turns out that the gases that were transparent to incoming short wavelength light are completely opaque to outgoing long wavelength infrared heat. There are impurities in our atmosphere, so-called greenhouse gases. The main ones are water vapor, carbon dioxide, methane, and nitrous oxide. Their molecular structure is such that they perfectly absorb this outgoing infrared radiation. They begin to vibrate, heat up, and in turn, re-emit this heat in all directions, including back down to the Earth's surface. The simplest analogy is a car left in the sun. Its windows easily let in visible light, which heats the seats and dashboard. The heated surfaces begin to emit infrared heat, but the car windows are not as transparent to it. The heat gets trapped. As a result, the temperature inside the car becomes much higher than the temperature of the air outside. Our atmosphere is the same giant glass enclosure surrounding the entire planet. Without this natural greenhouse effect, the average temperature on Earth's surface would not be a comfortable plus 15 degrees Celsius, but a chilling minus 18. Our planet would be a frozen ball, covered in ice from pole to equator. Life, at least as we know it, would be impossible. The atmosphere. This cunning jailer lets in the sun's rays as guests, but then locks the door and doesn't let their heat back out, forcing it to work to heat our planetary prison. It is the perfect accomplice, maintaining the ideal balance. But therein lies its main vulnerability. The balance is fragile. Studies like the famous Titus report, which analyzed the consequences of nuclear war, showed how sensitive this system is. The release of large amounts of dust and soot into the atmosphere can block incoming sunlight and cause a nuclear winter effect. On the other hand, an increase in the concentration of greenhouse gases, which trap outgoing heat, leads to global warming. Our guardian angel, our accomplice, can at any moment turn into a traitor if we disrupt the fine-tuning of its mechanism. We have understood how our protector works, but to definitively prove its guilt in maintaining our warmth, its indispensability, we, as true detectives, need to conduct an investigative experiment. We must journey through the solar system and visit worlds where this guardian angel is either dead or was never born. We need to see with our own eyes what happens when a planet is left alone with the ruthless cosmos, and we will see what true hell of contrasts is. Our investigation requires physical evidence. Theories alone, no matter how coherent, are not enough. We need an investigative experiment that vividly demonstrates the role of our main accomplice, the atmosphere. For this, we leave the cozy cradle of Earth and embark on a short tour of neighboring celestial bodies, which will serve as our control samples. It will be an excursion to dead, but incredibly talkative worlds for a detective. Our first stop will be the Moon. The Moon is the perfect testing ground for our theory. It is at practically the same distance from the Sun as Earth, meaning it receives almost the same amount of solar energy per square meter, but it lacks the key element, a dense atmosphere. What it does have is an exosphere, so rarefied that it can be considered almost a perfect vacuum. There is neither a shield nor a blanket here. The planet stands before space completely naked, and the consequences are astounding. Let's land on the lunar surface in the equatorial region. The sun is high in an absolutely black sky. Even during the day, there is no blue haze, no scattered light. The shadows here are not just dark, they are absolutely black, like abysses into oblivion. Under direct sunlight, the surface of the lunar regolith, fine gray dust, absorbs all the energy without residue. The temperature rapidly rises and reaches 127 degrees Celsius. This is more than enough to boil water, if it could exist there in liquid form. An astronaut's spacesuit becomes a personal life support system, desperately struggling with the external heat. But we only need to take one step and go into the shadow of a large boulder, and the situation changes dramatically, as if an invisible switch has been flipped. Since there is no air to mix and smooth out the temperature, cosmic cold reigns in the shadow. The temperature here instantly drops below zero, but the real hell begins with sunset. The lunar day lasts about 14 Earth days, and it is followed by an equally long night. As soon as the sun's disk disappears beyond the horizon, a catastrophe begins. Deprived of incoming energy and having no atmospheric blanket to retain the heat accumulated during the day, the lunar surface begins to rapidly radiate it directly into the icy void of space. The temperature drops, and drops, reaching a mark of minus 173 degrees Celsius. The temperature difference between day and night is 300 degrees. This is a world of ruthless, unimaginable contrasts for earthly life. It is a crystal house built on an artillery range. The moon is our proof number one. It vividly demonstrates what happens to a planet without an atmosphere. But perhaps the issue is that the atmosphere must be not just any, but exactly like Earth's. To check this, we travel further to our next destination, Mars. The red planet is a completely different case. Mars has an atmosphere, but it is merely a pale shadow of Earth's. It consists mainly of 95% carbon dioxide, a powerful greenhouse gas. It would seem that this should create a strong greenhouse effect, but the whole problem lies in its density. The atmospheric pressure on Mars's surface is less than 1% of Earth's. It is not a blanket, but rather a thinnest, holy gauze. It is too rarefied to effectively retain heat. Let's turn to the readings of our impartial witnesses, NASA rovers like Curiosity and Perseverance, which have been keeping a log at the crime scene for many years. Their data paints a picture of a world of missed opportunities. On a summer day at the Martian equator, the surface temperature can rise to a quite comfortable plus 20 degrees Celsius. One could walk around in a light jacket. This deceptive warmth gives false hope, making one think that Mars is not so bad. But as soon as the sun begins to set, the thin carbon dioxide blanket proves powerless. The heat accumulated during the day rapidly dissipates into space. At night, the temperature drops to minus 73 degrees, and this is at the equator. Closer to the poles, it can drop to minus 125 degrees, cold enough for the atmospheric carbon dioxide itself to freeze and deposit on the surface as dry ice. A daily temperature fluctuation of 100 degrees is the norm. This is a world of eternal exhausting depression, where brief moments of warmth are replaced by a long and piercing chill. Now we can summarize our investigative experiment. We have 3 folders before us. Case number 1. The moon without an atmosphere. Result: hellish temperature swings from boiling to deep freeze. Case number 2. Mars with an extremely rarefied atmosphere. Result: an icy desert with brutal diurnal temperature fluctuations. And case number 3. Earth with a dense, multi-layered atmosphere and a balanced greenhouse effect. Result: a stable temperate climate, oceans of liquid water, and a thriving biosphere. The verdict is obvious and cannot be appealed. It is the atmosphere, our main accomplice, that is the key factor turning a planet from a dead rock into a cradle of life. It is our shield and our blanket, without which we would be defenseless. We have seen how Earth, our warm and cozy home, can instantly turn into an uninhabitable world. We have understood how warmth is preserved, but throughout this investigation, we have taken the very source of this warmth for granted. We have spoken all along of photons, of sunlight, but where does it come from in such unimaginable quantities? What is this perpetual motion machine that has been running for 4.6 billion years? In the next chapter, we will stop talking about the consequences and move on to the primary cause. We will descend into the very heart of our star, into its thermonuclear furnace, to witness the birth of photons and observe processes so powerful that they make the laws of our world crack at the seams. Until now, our investigation has concerned what happens here, on the outside, in the cold and dark halls of space. We have studied clues, interrogated witnesses, checked alibis. We have understood how heat is transferred and how our planet manages to preserve it. But all this time, we have been beating around the bush, avoiding the main culprit, the very source of this grand process. We have spoken of its light, of its energy, but not of it itself. It is time to stop investigating based on circumstantial evidence. It is time to pay a visit to the main suspect. We are heading into the very inferno, into the lion's den, to the place where light is born. We are making a journey into the heart of the sun. The scale of our investigation changes again, and this time, as radically as never before. We leave behind planetary landscapes and dive into the substance of a star. Forget everything you know about the ordinary world. Our earthly concepts do not apply here. Matter exists here in a fourth exotic state, the state of plasma. It is an ionized gas where, due to monstrous temperature, atoms have disintegrated into their constituent parts. Electrons are torn from their orbits and roam freely, separate from atomic nuclei. It is a boiling, seething soup of elementary particles. We descend into the core, and here the conditions become truly unimaginable. The pressure reaches 265 billion Earth atmospheres. That's like placing the weight of all the cars on the planet on your fingernail. The temperature is 15 million degrees Celsius. No substance known to us can exist here in solid or liquid form. Everything is pure, unbridled energy. It is here, in this thermonuclear hell, that the factory producing light is located. Our intuition, our old acquaintance, tries to give us a simple explanation again. It's burning, it whispers. The sun is just a very big campfire. But this is the biggest mistake one can make. Burning is a chemical reaction, an oxidation process where atoms rearrange into new molecules, releasing energy. If the sun burned like coal, it would have burned out and extinguished in just a few thousand years. No. What happens here is a process of a completely different order. This is not chemistry. It is nuclear physics in its most brutal and beautiful manifestation. It is thermonuclear fusion. Here, in the core, the main process occurs, known as the proton-proton cycle. Billions and billions of protons, positively charged nuclei of the simplest element, hydrogen, rush through this plasma at monstrous speeds. Under normal conditions, they would never combine. Like poles of a magnet, they repel each other with immense force. But here, under conditions of unimaginable pressure and temperature, they are compressed so strongly that they overcome this repulsion. They collide and merge. This is not just a collision, it is transmutation, alchemy, which medieval scholars dreamed of. Hydrogen turns into helium. Let us imagine this through an analogy understandable to our earthly mind. An analogy with currency exchange rates. Imagine you have 4 hydrogen rubles. These are our 4 protons. You bring them to a stellar exchange office, the sun's core, and want to exchange them for a more stable and heavier currency. As a result of a complex reaction, passing through several stages, you receive 1 helium euro in your hands. 1 helium nucleus, consisting of 2 protons and 2 neutrons. But here's the catch. If you put your initial 4 rubles and the resulting euro on ultra-precise scales, you will discover something strange. The helium euro will be approximately 7%, lighter than 4 hydrogen rubles. Where did this missing mass go? It did not evaporate, it did not disappear. It turned into something completely different. And here, our main witness enters the stage, who explained this process without even seeing it, a witness named Albert Einstein. In 1905, he derived the most famous equation in human history, E equals mc squared. Energy equals mass multiplied by the speed of light squared. It is a simple formula, the key to understanding the power of the universe. It tells us that mass and energy are two sides of the same coin. Mass can be converted into energy and energy into mass. And the coefficient of this exchange is colossal. It is the speed of light raised to the power of 300,000 kilometers per second multiplied by themselves. This is a gigantic number. It means that even a tiny microscopic loss of mass m releases an unimaginably monstrous amount of energy E. That very missing particle of mass, the 7% that was lost in the exchange of hydrogen for helium, is precisely the price the sun pays. This mass transforms into pure energy in the form of gamma quanta and neutrinos. Every second, in the sun's core, about 600 million tons of hydrogen turn into helium. And in the process, approximately 4 million tons of material mass, 4 million tons of substance, disappear every second, transforming into light and heat. It is as if the weight of 100 aircraft carriers was converted into pure energy every second. It is at this very moment that our old acquaintance, the photon, is born. It is born as a high-energy gamma quantum, but its path outward will be long and arduous. It cannot simply fly out of the core. The density of matter here is so great that before it can travel even a fraction of a millimeter, it immediately collides with some particle, is absorbed by it, and is immediately re-emitted in a random direction. And so, again and again, its path resembles that of a drunkard trying to get out of a dense crowd. He takes a step forward, 2 steps to the side, a step back. He is imprisoned in this stellar jail. This journey, this frenzied dance in incandescent plasma, takes from 10,000 to 170,000 years. 100,000 years of agonizing ricochets within the star. Before one of these photons, having lost much of its initial energy, finally reaches the sun's surface and bursts into open space to reach Earth in 8 minutes. We have seen the source of energy. We have understood how it works. It seems all the main clues have been gathered. We have traced the entire path from the birth of a photon in thermonuclear hell to its absorption on Earth, but we have only considered normal conditions, the standard operation of the system. What will happen if something foreign and incredibly fast invades our well-regulated system? What if a guest from another galaxy flies into our quiet backwater, whose energy will cause the laws of physics, which we considered immutable, to behave like madness? In the next chapter, we will stop talking about heat and light and talk about pure violence. We will consider a scenario where a particle enters our atmosphere, accelerated to a speed unattainable in any terrestrial accelerator. Until now, only local forces have featured in our investigation: the sun, Earth, the atmosphere. It was a family drama playing out within the solar system. But the universe is vast, and there are forces within it compared to which our sun is merely a quiet harbor. It is time to introduce a new player into our case. It is not a star and not a planet. It is a single, almost invisible particle, a proton or an atomic nucleus. But it is not an ordinary proton. It is a ghost from another world, a perfect killer that has traveled through the intergalactic void for millions of years to deliver a single strike. The name of this player is a cosmic ray of ultra-high energy. These are not rays of light. They are actual particles of matter, accelerated to speeds almost indistinguishable from the speed of light. Their sources are the most ferocious and catastrophic events imaginable: supernova explosions, jets erupting from the vicinity of supermassive black holes at the centers of galaxies, collisions of neutron stars. These cosmic cataclysms act as giant natural accelerators, accelerating particles to energies millions of times greater than those achievable at the Large Hadron Collider at CERN. And now, one of these particles, after millions of years of travel, approaches Earth. What happens next? Here, our earthly Newtonian intuition completely and irrevocably fails. We are accustomed to thinking that if we double the speed of an object, its energy will quadruple. But this only works for low speeds. When the speed approaches the speed of light, the laws discovered by the same witness who gave us E equals mc squared, Albert Einstein, come into play. This is his special theory of relativity. It states that the speed of light in a vacuum is the absolute speed limit in the universe. Nothing can move faster. And as this limit is approached, strange things begin to happen to the object. For us, observers, its time slows down, and its mass begins to increase. This does not mean new particles stick to it. It is its own kinetic energy. According to the very same equation, it begins to manifest as additional relativistic mass. The closer the speed is to the speed of light, the more energy is needed to accelerate it even a little further, and the more its effective mass increases. For a particle traveling at 99.99 and many, many more nines after the decimal point, percent of the speed of light, its energy, and therefore its impact mass, can become colossal. A single proton can carry kinetic energy comparable to the energy of a baseball bat traveling at 100 kilometers per hour. All this monstrous power is concentrated in an object smaller than 1/1,000,000th of a centimeter, and this object flies into the upper layers of Earth's atmosphere. To understand what happens next, let's use an analogy. Imagine you are jumping into a swimming pool from a diving board. For you, the water is liquid and yielding. Now imagine you are jumping into the same pool at the speed of a flying bullet. At the moment of impact, the water will seem not soft, but hard as a concrete wall. The water molecules simply will not have time to move out of your way. Similarly, for our ultra-fast particle, the Earth's atmosphere, usually a near-transparent void, suddenly turns into a dense, impenetrable wall. A collision occurs. The relativistic proton crashes into the nucleus of a nitrogen or oxygen atom in the air, and this impact releases all the accumulated energy in a single fiery flash. But it is not just an explosion, it is a birth. A blow of such force generates a whole fountain of new, unstable particles that do not exist in our ordinary world. Pions, kaons, and other exotic forms of matter. These newborn particles also fly with enormous energy and, in turn, collide with other atomic nuclei, generating more and more new particles, and so on. A single particle triggers a chain reaction, a cascade. This phenomenon is called an extensive air shower. Above our heads, at an altitude of 10 to 20 kilometers, invisible to the eye, a gigantic spectral fiery flower blooms. It consists of billions of secondary particles, electrons, positrons, muons, and photons, which rush towards Earth's surface like an avalanche, covering an area of several square kilometers. It is these showers that are registered by the detectors of giant observatories, such as the Pierre Auger Observatory in Argentina. From the nature of this particle rain, scientists can reconstruct the energy and direction of arrival of the primary killer. We have seen how one tiny invisible particle from the depths of space can cause a cascade comparable in total energy to the explosion of a small bomb. This was a collision in the atmosphere. Our guardian angel, like a shield, took the blow upon itself, dispersing its energy. But what if the object were larger? What if it were not a proton, but an asteroid? Say, the size of a small city. What if the impact were not on rarefied air, but directly on the planet's solid crust? We will switch from particle physics to geology and paleontology. We will perform an autopsy of the planet itself to see the scars of ancient catastrophes and understand what a real direct impact is. We will learn how, in a matter of hours, an entire world can be wiped off the face of the Earth. Our investigation changes scale again. From invisible particles, we move to objects that can be seen with the naked eye. From particle physics, we move to geology and paleontology. We become planetary forensic scientists, performing autopsies of the Earth itself. Our task is to find scars of ancient crimes on its body and reconstruct the picture of the most massive murder in our planet's history. Our new subject of investigation is an asteroid, 10 kilometers in diameter. And the time of the crime was 66 million years ago, the end of the Mesozoic era. For a long time, the case of the dinosaur extinction was unsolved. There were many theories: climate change, volcanic eruptions, epidemics. There were no direct clues pointing to one specific culprit. But in 1980, a team of detectives led by father and son Luis and Walter Alvarez stumbled upon a key piece of evidence. Studying geological layers in Italy, they discovered a thin layer of clay that precisely corresponded to the boundary between the Mesozoic and Cenozoic eras, the moment when the dinosaurs disappeared. Analysis of this clay showed an abnormally high concentration of iridium, a metal very rare on Earth but abundant in asteroids and comets. This was the shell casing left at the crime scene. Soon, this iridium layer was found all over the world. This meant the catastrophe was global. The Alvarez team put forward a theory. A giant asteroid crashed into the Earth, and it was this event that caused the mass extinction. But every good detective needs not only a clue, but also a body, a crime scene. For 10 years, the whole world searched for the giant crater that should have remained from such an impact. And in the early 90s, it was found, hidden under a kilometer-thick layer of sedimentary rocks, half on land and half underwater, on the Yucatan Peninsula in Mexico. The Chicxulub crater. Its diameter is 180 kilometers, and its depth is 20 kilometers. The murder weapon was found. Now we can reconstruct the crime scene minute by minute. Imagine the world 66 million years ago, a world of humid tropical forests and giant lizards. And then, a new blindingly bright star appears in the sky. With each second, it becomes brighter, turning into a second sun. This is our asteroid entering Earth's atmosphere at a speed of about 20 kilometers per second. Due to friction with the air, it heats up to 1,000 degrees. Then, the impact. The moment when a 10-kilometer rock crashes into the shallow waters off the coast of an ancient continent. At this instant, energy is released that our minds cannot comprehend. 100 million megatons in TNT equivalent. It is as if you detonated the entire accumulated nuclear arsenal of humanity simultaneously and multiplied that power by 10,000. The first thing that happens is the shock wave. It spreads from the point of impact, vaporizing ocean water, rock, and the asteroid itself. The explosion throws trillions of tons of rock into the atmosphere, beyond its limits. Seismic waves of a force that cannot be measured on the Richter scale pass through the planet. This is an earthquake of 13 to 14 points. The Earth rings like a giant bronze bell from this impact. Volcanoes erupt, and monstrous landslides begin worldwide. Second, the firestorm. The rock ejected into space does not fly away forever. Under the influence of gravity, it begins to fall back to Earth. Billions of tiny, incandescent particles known as tektites enter the atmosphere across the planet like a meteor shower of unprecedented density. They heat the upper layers of the atmosphere to the temperature of a working oven. This global celestial grill ignites forests and dry vegetation worldwide within hours. The planet is engulfed in fire. Third, the mega tsunami. The impact in the ocean generates waves of unimaginable height, not tens, but hundreds of meters. Some estimates speak of waves up to 1.5 kilometers high that travel hundreds of kilometers inland, washing away everything in their path. And when it seemed the worst was over, the most terrible thing arrived. A quiet, slow death. Billions of tons of dust, soot from global fires, and sulfur compounds from vaporized rocks are ejected into the stratosphere. They create a dense, impenetrable screen that envelops the entire planet. Sunlight can no longer penetrate to the surface. An impact winter begins. Night falls on Earth, lasting for years. The surface temperature drops sharply. Without light, photosynthesis stops. Plants die. Then the herbivorous dinosaurs die, having nothing to eat. And after them, the predators, having lost their prey. Food chains collapse like a house of cards. Oceans acidify due to sulfurous rains, destroying plankton, the basis of marine life. In geological samples from the impact site, we find evidence, fingerprints of this event. These are minerals such as coesite and stishovite, forms of quartz that can only form under conditions of instantaneous, unimaginable high pressure. This is irrefutable proof of the impact origin of the catastrophe. Although some scientists still consider other suspects, for example, the massive eruption of the Siberian traps, the impact theory, to date, has the greatest amount of evidence. We have seen how Earth, our warm and cozy home, can instantly turn into a glass house on an artillery range. One impact from space can nullify millions of years of evolution. We have traveled the whole journey, from the simple question about the night coolness to a global catastrophe that destroyed an entire world. Why did we undertake this entire journey? In the final chapter, We will summarize our long and complex investigation and deliver the final verdict. But it will not be a verdict on the cosmos. It will be a verdict on ourselves and our place in this vast and indifferent universe. We are at the finale of our investigation. Behind us lie interrogations, investigative experiments, autopsies, and dossiers on witnesses whose names are Planck, Einstein, Sagan. All the evidence gathered during this long journey is laid out on the table before us. From the barely perceptible feeling of night coolness to the scars on the planet's body left by an asteroid, each piece of evidence led us further and further away from the familiar world, deeper into the cold, indifferent reality of space. It is time to put them together and deliver the final verdict. Let us go through the case files one last time. We began with a simple question. Why is space cold? Our main suspect, intuition, gave us a simple answer. Because it is far from fire. But we proved that this answer is false. Clue number 1. Kinetic theory showed us that temperature is nothing more than the motion of particles. No particles, no temperature. This was the first blow to common sense. Clue number 2. The 3 modes of heat transfer proved that neither conduction nor convection works in a vacuum. Only radiation remained, photons flying from the sun. Clue number 3. The very nature of the photon revealed the main secret to us. Light is not heat. It is merely a carrier of energy, a baseball flying through the void. To become warm, it needs to be caught. Empty space, which has almost no matter, is a field without players. The photons simply fly past. And when it seemed the case was solved, we stumbled upon clue number 4. The ghost of the Big Bang, the cosmic microwave background radiation. We learned that the universe has its own baseline temperature, its own background glow. This is the temperature of the cooling embers of the creation fire, an inevitable cold that permeates all existence. Having solved the case of the cold, we opened the case of the heat. How do we survive in this icy realm? And clue number 5. The atmosphere gave us the answer. Our accomplice, our guardian angel, working as both a shield and a blanket. It blocks deadly radiation and traps outgoing heat through the greenhouse effect. Our journey to the moon and Mars, control samples of dead worlds, undeniably proved its indispensability. Finally, we peered into the very heart of the beast. Clues number 6, 7, and 8. Thermonuclear fusion. Relativistic particles and asteroid impacts showed us the true face of the universe. It is not just cold, but an unimaginably cruel and violent place. A place where matter transforms into energy, where single protons carry the energy of bullets, and rocks the size of cities can nullify an entire biosphere. All clues are collected, witness testimonies heard. Now, based on all of the above, the court delivers its verdict. Our main suspect, intuition, also known as life experience, also known as common sense, is found guilty. But guilty of what? Not of malice, not of an attempt to deceive us. It is guilty of incompetence, born of the limitations of its world. It is a brilliant detective for investigations within a single room, a single planet. It has impeccable understanding of how a campfire burns and tea cools, but it is absolutely helpless, pathetic, and blind when it comes to the laws of the universe. Its experience is the experience of an inhabitant of a small, quiet, anomalously warm village trying to judge the laws of a gigantic, icy, and indifferent metropolis. It is not a liar. It is simply a provincial. At this point, the investigation is declared closed. The case of the cold in space is closed, but what does this knowledge give us? A dry protocol, filed in a folder? No. By solving this case, we arrive at the most important discovery, which lies beyond physics. A metaphysical discovery. The realization of how rare and fragile the conditions necessary for our existence are. Our planet, our warm blue world, is not the norm. It is an incredible, almost impossible anomaly. It is a tiny, barely noticeable oasis of life built against all the laws of the surrounding desert. It is a fragile glass house that has miraculously survived amidst an endless artillery barrage. In 1990, at the request of our great witness Carl Sagan, the spacecraft Voyager 1, already leaving the solar system, turned one last time to take a picture of its home. From a distance of 6 billion kilometers, Earth appeared in this picture as a single, barely discernible point, a bluish speck lost in the rays of scattered sunlight. Sagan called this photo pale blue dot, and here are his words, which we are obliged to enter into our record. Look again at that dot. That's here. That's home. That's us. Everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives on it. The sum of our joys and sorrows, thousands of confident religions, ideologies, and economic doctrines, every hunter and gatherer, every hero and coward, every creator and destroyer of civilization, every king and peasant, every in-love couple, every mother and every father, every capable child, inventor and traveler, every ethics teacher, every corrupt politician, every superstar, every greatest leader, every saint and sinner in the history of our species, all of them lived here, on this speck of dust, suspended in a sunbeam. Our investigation into the coldness of space inevitably leads us to the conclusion about the pricelessness of warmth, not the physical warmth of a star, which, as we have found out, is merely impersonal energy, but warmth of a different kind, the warmth of life, the warmth of consciousness, the warmth of civilization. This entire vast, cruel, and indifferent universe, with all its nuclear fusion, supernova explosions, icy emptiness, and cosmic microwave background radiation. All these 13.8 billion years of matter's evolution were needed for one tiny planet in the thinnest film of biosphere, for a short, almost imperceptible moment by cosmic clocks, a being capable of raising its head, looking at the stars, and asking the question, why is it so cold out there? This question is perhaps more important than any answer. Its very existence is the greatest paradox and the greatest miracle. And it proves that even in the deepest and darkest void, there is at least one warm spot. That's us. Our past investigation is concluded. The case file on the coldness of space and the fragility of our world has been sent to the archives. The verdict has been rendered, but the detective's work never ends. Having solved one case, you inevitably stumble upon a thread leading to the next, even darker and more tangled one. We sit in the dimly lit office of our minds. Outside the window is the velvet blackness of space, which we have just interrogated. But now our gaze is directed not outward, but inward. We look at our reflection in the window pane and ask a new question. A question that makes blood run colder than any cosmic chill. In the last chapter, we concluded that what has value is not just warmth, but the being capable of asking the question, why us? But who is this us? What is this I that thinks these thoughts, that feels satisfaction from a solved case and anxiety before a new one? Where does it sit? A new investigation begins. Case number 11. The case of the ghost in the machine. The ghost is our consciousness, our self, our inner voice, which is reading these words right now. The machine is the 3-pound bag of electric jelly that we call the brain. And our main suspect this time is this very self. Its testimony seems impeccable. It claims, I am in charge here, I am the driver, I am the thinking center that sits somewhere behind the eyes and controls this body like a puppet. I am the single, whole, and indivisible master of this skull. It sounds convincing as intuition once sounded about the sun being just a big bonfire. But we have already learned from bitter experience. We know that the most convincing testimonies most often turn out to be the most brazen lies. And we begin the search of the crime scene. We have to break open this machine and find the ghost in it, find the throne room where this self-proclaimed ruler sits. We dive into the brain. And what do we see? The picture is not like an ordered mechanism. It's not a computer with a central processor. It's a city, no, a giant, pulsating, living city, plunged into eternal night. A city with no streets, only endless intertwined wires. A city inhabited by the most populous inhabitants on the planet, about 86 billion residents. The name of each resident is a neuron. A neuron is our main informant. Taken separately, it is not so very smart. It's just a cell with long extensions, axons, and dendrites. It can do only two things, be silent or scream. Receiving enough signals from its neighbors, it explodes, generates a short electrical impulse that runs along its extension, the axon, to other neurons. Yes or no, 0 or 1. Silence or scream. That's all one inhabitant of this city can do. But there are 86 billion of them. That's almost as many as there are stars in our Milky Way galaxy. Each of these resident neurons is connected to thousands of others. The points of their contact, the places where they have their quiet conversations, are called synapses. And the total number of these connections, these conversations happening in your brain right now, at this very second, exceeds 100 trillion. Some estimates bring this number up to a quadrillion. That's more than the number of stars in all the galaxies of the observable universe. Before us is not just a city. Before us is an entire universe of flesh and blood, locked in a cramped bony box. And here we are, detectives, wandering through this city in search of the mayor's office, in search of the control center. We walk along bundles of nerve fibers, like along avenues. We see separate districts. Here is the visual quarter at the back of the head, where information from the eyes is processed. Here is the auditory area in the temporal lobes. Here is the motor department, responsible for movement. We see specialized centers, offices, departments. But where is the CEO's office? Where is that single neuron, that single structure that receives all information and makes the final decision? That is our self. We search, but we don't find it. We sift through trillions of connections, interrogate billions of neurons, but not one of them says, "Yes, I am in charge." The deeper we dive, the clearer the terrifying truth becomes. It doesn't exist. There is no center, there is no throne, there is no driver in the machine. There is only the city, there is only the network, there is only the hum of 86 billion voices, whispering, screaming, and arguing with each other in the darkness. The testimony of our main suspect, the single and whole self, has suffered its first monstrous crack. It claimed to be the ruler. And we haven't even found its office. We have found only a noisy, anarchic, self-organizing metropolis. This discovery calls into question our entire investigation. If the self is not a specific place, then what is it? Perhaps it's not a resident, but the song of this city itself? Perhaps it's the result of their communication? We stand on the threshold of a new, even deeper level of this case. We have studied the hardware. We have recounted the inhabitants. We need to go deeper and understand how their language works. We have to eavesdrop on their whispers in the darkness and interrogate the most elusive piece of evidence, the synapse. And what we learn there will make us doubt not only who we are, but whether our world is real at all. Chapter 12. Whispers in the dark. Interrogating the synapse. We have failed. Our first foray into the city of neurons yielded no results. We were looking for a control center and found only a decentralized humming network. The ghost we are looking for, ourself, does not sit in the director's chair. It is dissolved in the very air of this city. Our investigation is changing tactics. If we cannot find the culprit, we must understand how his criminal scheme works. We must study the language spoken by the inhabitants of this city. We shift our attention from the neuron to the space between neurons. Our new witness is the synapse. The synapse is not a thing, it is a process. It is a microscopic gap, a chasm between the extension of one neuron and the body of another, only 20 nanometers wide. It is a border zone, a customs post, through which information is transmitted. When an electrical impulse, that scream, running along the neuron's corridor, reaches the end, the synapse, it cannot simply jump over this abyss. Electricity is powerless here, and then something amazing happens. The electrical signal turns into a chemical one. Imagine two buildings standing very close to each other. You need to pass a note from a window of one building to a window of the other, but you can't jump. So the person in the first building writes the note, puts it in a capsule, and shoots it from a pneumatic gun. The capsule crosses the abyss and lands in a special receiver on the wall of the second building. The person in the second building takes the note, reads it, and based on it decides what to do next: scream themselves or remain silent. This is the work of the synapse. The end of the first neuron. The presynaptic membrane is our first building. It contains tiny sacs, vesicles, filled with special substances. These substances are our encrypted notes. They are called neurotransmitters. When an electrical impulse reaches this end, it causes the vesicles to fuse with the membrane and release their contents into the synaptic cleft. Neurotransmitters, couriers, rush across the abyss to the second neuron. On the surface of the second neuron, the postsynaptic membrane, there are special proteins, receptors. These are our receivers, locks, to which only specific keys and neurotransmitters fit. When a neurotransmitter binds to its receptor, it either excites the second neuron, pushing it towards screaming, or, conversely, inhibits it, forcing it to remain silent. This is a complex chemical dance. And each courier, each neurotransmitter has its own specialization, its own role in this drama. Dopamine is not a molecule of happiness. It is an informant promising a reward. It whispers, "Do it again. This was important for survival. You are on the right track." It is responsible for motivation, learning, and striving for goals. Serotonin is not a hormone of joy, but rather a stern peacemaker, a patrolman who ensures the general order in the city. It regulates mood, appetite, sleep, smoothing out peaks and troughs, preventing the system from going haywire. Norepinephrine and epinephrine are alarm agents. They shout, "Attention, danger, mobilize all resources, fight or flight." Glutamate is the main exciter screamer, and GABA is the main inhibitor silent one. Hundreds of trillions of such chemical conversations happen in your brain every fraction of a second. Every breath you take, every finger movement, every thought, every memory is a unique, unrepeatable pattern of trillions of these whispers in the darkness. And here we come to the solution of our ghost's mystery. Our consciousness, our unified and smooth self, is an illusion born from this chaos. It's like a movie in a cinema. We see smooth, continuous motion on the screen, but we know that in reality, it's just a rapid sequence of individual static frames, 24 pictures per second. Our brain does the same trick. It takes billions of discrete, intermittent signals, yes or no, from neurons and stitches them into the smooth, continuous fabric of our subjective experience. Our self is not a spectator watching a movie. Our self is the movie itself, which the brain shows to itself. And we have irrefutable proof that the self is not a monolithic ruler, but rather a coalition government of several competing factions. The evidence is called a split brain. In the middle of the 20th century, for the treatment of severe forms of epilepsy, surgeons sometimes resorted to radical surgery. They severed the corpus callosum, a thick bundle of nerve fibers connecting the left and right hemispheres of the brain. The epilepsy subsided. But studies of these patients, conducted by Roger Sperry and Michael Gazzaniga, led to a shocking discovery. It turned out that in one skull, two different consciousnesses now lived, practically two different personalities. As we know, the left hemisphere in most people is responsible for speech and logic, and the right for visual thinking and spatial perception. And the left hemisphere controls the right half of the body, and the right controls the left. In a normal brain, they constantly communicate, but in these patients, the connection was severed. If such a person is shown a picture only with the left eye, whose information goes to the right hemisphere, he will not be able to name what he saw because the speech center in the left hemisphere did not receive this information. But his left hand, controlled by the right hemisphere, will be able to draw or choose this object from a pile of others. It turns out that one part of his brain knows the answer but cannot say it, and the other can say it but does not know the answer. But the most amazing thing was yet to come. Michael Gazzaniga discovered a phenomenon that he called the interpreter of the left hemisphere. If a command is given to the right hemisphere, for example, by writing the word "go" so that only the left eye sees it, the person will get up and walk. But if you then ask him, "Where are you going?" his speech center in the left hemisphere, which did not receive this command and has no idea about the reason for this action, will not say, "I don't know." He will instantly come up with a plausible explanation. He will say, "I'm going for a Coca-Cola." He is lying. Not because he is a deceiver, but because his job is to create a coherent, logical story of our behavior. He is a staff press secretary, a PR agent who constantly concocts press releases to explain the actions of his boss, even if he himself does not know the true motives. This discovery is a fatal blow to our main suspect. Our self, our inner voice, which we considered the source of our decisions, is in reality often just their ex post facto justification. It is not the director, but rather a film critic who writes a review of a film that has already been made by others. Deeper and more silent parts of his brain. We have shattered the monolith. We have proven that our self is not a king, but a fragile coalition, and with a lying press secretary, no less. The ghost turned out not to be a single spirit, but a whole legion of little chattering demons. But if our inner self is such a complex and unreliable construction, then what can be said about the world that this self perceives? If the detective turned out to be an illusion, can the evidence he collects be trusted? Our investigation is approaching its final, most terrifying chapter. We have to find out that the world we see, hear, and touch is just as grand a fabrication as our own self. Chapter 13. Counterfeiters. The Case of Manufactured Reality. Our investigation hangs by a thread. We began by looking for a ghost in the machine and discovered that there is no driver in the machine, only a noisy parliament of billions of neurons. Then we found out that the chairman of this parliament himself, ourself, is not so much a leader as a press secretary, explaining accepted decisions retroactively. The detective leading this case turned out to be an illusion. What could be worse? Only one thing could be worse. If the crime scene itself, the entire surrounding world, also turns out to be an illusion. This is our final task. Case number 13. We are accustomed to thinking of our senses, eyes, ears, skin, as wide-open windows through which we look at an objective world existing independently of us. This is the last testimony of our intuition, and it is its last and most important lie. The truth is that our senses are not windows. They are field agents working in a hostile and incomprehensible environment. They collect only fragments of information, tiny pieces of data, and send them to headquarters, to the brain, in the form of encrypted dispatches, in the form of simple electrical impulses. And it is there, in the dark offices of the brain, that other agents, analysts, try to reconstruct a complete picture of what is happening from these fragments. And they do not just reconstruct, they invent, they embellish, they lie. Let's start with the main witness, vision. We think of the eye as a video camera that transmits a picture to the brain. This is not true. To begin with, in the very center of our field of vision, where the optic nerve attaches to the retina, we have a blind spot. There are no light-sensitive cells there. Right now, in your visual field, there are 2 holes the size of a full moon. You don't see them. Why? Because your brain, this skillful counterfeiter, simply covers up these holes by copying the texture and color from the surrounding areas. It creates a seamless picture, although in reality there is a huge gap in the data. It lies to you every second, simply for your convenience. But this is just the beginning. The most grandiose lie of vision is color. We see the world in color: green grass, blue sky, red sunset. We are sure that color is a fundamental property of objects, but it is not. In objective physical reality, there is no color at all. There are only electromagnetic waves of different lengths. That's all. Light reflected from the grass has one wavelength, light from the sky has another. These waves hit the retina, excite one of the 3 types of our cones. And this information, in the form of impersonal electrical impulses, goes to the visual cortex. And only there, in the neural network at the back of your head, does the brain arbitrarily assign different subjective sensations, which we call color, to these different wavelengths. Color is a user interface created by evolution. It's a system of icons on a desktop. The color red is not a property of an apple. The color red is an icon that your brain draws for waves of a certain length to tell you, attention, this fruit is ripe, it has a lot of sugar, it is a valuable source of energy. Blue is just another icon. The entire colorful world you see is painted inside your skull. The real world beyond it is most likely colorless and flat. And our interface is extremely primitive. We have only 3 types of cones. Some birds and reptiles have 4. The mantis shrimp, that marine psychopath, they have 12. We cannot even imagine the colors they see. Our colorful reality for them is like a black and white movie. The same applies to sound. Sound is not a property of a falling tree. In the world, there are only vibrations of air molecules, waves of compression and rarefaction. These waves hit our eardrum, and a complex mechanism in the ear converts them into electrical signals. And only the brain interprets the different frequencies of these vibrations as high or low pitch, as music or noise. But the most insidious illusion is time. We perceive time as a smooth, continuous river flowing from the past to the future through a single moment that we call now. This is also a lie, fabricated by the brain. The fact is that signals from different sensory organs reach the brain at different speeds. Light from a lightning flash reaches you almost instantly, and the sound of thunder later. Information from touching your leg takes longer to reach the brain than from touching your nose. If the brain showed you reality in real time, your world would be a desynchronized chaos. What does it do? It works like a news editor. It does not broadcast information live. It first collects all the reports from the scene, from the eyes, ears, skin, which arrive with delays. Then it waits for a fraction of a second, synchronizes them all, edits them into a single smooth, logical story, and only then delivers it to you as a finished news broadcast. This is your now, with one small nuance. You always live in the past. Your consciousness is always slightly behind reality, about half a second. When you think you are making a conscious decision, your brain has already initiated that action a fraction of a second before you thought about it. Your now is actually just a moment ago. It's a fresh memory. So, let's summarize our last, deepest investigation. We started with the premise that the universe is a cold, empty, and indifferent place. Our planet is a warm and fragile anomaly. On this anomaly arose the most complex structure in the universe, the human brain, a city of 86 billion neurons. This city, as we have discovered, generates the illusion of a single self, which is actually just a press secretary justifying the actions of subconscious mechanisms. And now we have proven that this illusory self lives in an illusory world, which the brain fabricates for it, coloring in a colorless reality, giving voice to soundless vibrations, and editing the past into a continuous present. What is the final verdict? The verdict is that we are stories. We are the narrative that the brain tells itself. We are characters in a book written by 86 billion authors who are simultaneously readers. We live in a world painted by these same authors on a tiny stage floating in an infinite dark and silent theater, and our entire life, our entire investigation, is merely an attempt by one of the characters in this book to peek at the page where it describes itself and read who it is. Case closed, and the accused, the victim, and the detective all turned out to be the same ghost. A ghost trapped not in a machine, but in the story it tells itself. Okay,